Alright students, so this video is talking about Math 3 2.6, which is all about parabolas. And in our class we've talked about three different types of parabolas. Let's look what they are. And let me correct that statement. These are three forms of quadratic equations. The shape is a parabola. So we call this a quadratic function, and the shape is a parabola. So these are all quadratic functions. The shape for all of them would be a parabola, either up or down, wide or skinny. So they're all going to be a parabola. What they also have in common is they all have the front letter A. And just a reminder, A controls whether it opens up or down. Okay, so we consider this we call this opening up, this one opening down. This is when A is positive or greater than 0. And this one is when A is negative or less than 0. So that's important. So generally we'll know the shape of it based on whether it's positive or negative just by looking at the front number. The rest of this though, and why do we have three different forms? Well, standard form, a lot of times it's useful to write like that. It sort of looks clean, but if we factor it, we can put it into intercept form. But in intercept form, we just know the intercepts. We don't know the vertex. So sometimes we want to complete the square and get it into vertex form. Okay, so generally, standard form can go into either form, and all of these can be changed from one to the other. If you have enough scratch paper, you can go backwards and forwards. But we use different P's and Q's and A's and B's and C's here because this P is not the same as this H. If you put in this form, the number you'd have would be different than this. So that's the point. The other videos went over standard form and intercept form, so today we are going to talk about vertex form. Before we do that, though, let's just go over this. It's in the family of x squared. These are all in the family of x squared. These all would be then parabolas because they're all x squared. And the parabola, this one would have a center at, or sorry, vertex at 0, 0. And a vertex is 0, 0. Okay. Now we've already discussed previously that putting a number inside would then shift it left or right. So this is a horizontal shift. Now we talked about that because our book does this in weird order, but the point is whether it's x squared, x cubed, x to the 4, x to the 90th, the number inside here is going to be a horizontal shift. The number at the end here will be a vertical shift. What that does to your graph is this. If it used to be at 0, 0, but you shifted it to the right by h and up by k, your vertex is now h, k. All right. So that's the advantage of vertex form. You'll know what the vertex is. Let's do an example. We could have y equals, oh, I need a number instead of a. Sorry. Let's go y equals 1/2 x minus 4 squared plus 1. Okay. So in vertex form, this is our h, or our horizontal shift. That's our k. And again, usually our vertex would be at 0, 0, but because of the minus 4, positive 4 is the new 0. Positive 4 is what makes this 0. All right. And when you plug in, you get a 0 there, you'll get a plus 1. So a positive 4 and a plus 1. Okay, let's say that again. What I think to myself here is, what makes this 0? We're not plugging in 0. Oh, there it is. What makes that 0? We're not plugging in 0, and we're not saying it's negative 4. Even though it's minus 4, it's the plus 4 that makes it 0. So even though it's minus 4, you just take the 4 value. Because what you're thinking is what makes that 0. Now that's your vertex. And what that helps you with is you know where you're located. You know you're over here at 4, 1. You know the vertex is here. Because of the 1/2, you know it opens upwards. So you know it has, whoops, I'm sorry, that's a little bit else. You know it has that general shape. Okay? So by having it in vertex form, you can locate the vertex and you'll know what general direction is going. If you want a better looking graph, you can always go back and do a table of values, and you should. Now that we know 4, we can do 3 and 2 and 1 and 0, and I'll leave those for you to do. But you should find that they end up with values that go along the parabola. All right, thanks for watching.